Welcome back to ABA Chapter Chat.
Great to be back.
Today, we're really digging into something core to, well, everything we do in ABA, graphing data.
Yeah, it's absolutely essential. We're focusing on Chapter 5 from Applied Behavior Analysis for Teachers.
And it's crucial, isn't it? Because, we collect all this data, hours of it sometimes.
Oh, definitely. You end up with these stacks, maybe digital stacks now, but still stacks of data sheets.
Right. And that raw stuff, those tallies, those notes, they don't always immediately tell you what's going on.
Exactly. Graphing is how we turn that pile into something useful, something that shows progress or lack thereof. It tells the story.
It really does. It's like finding the pattern in the noise. It lets us see if what we're doing is actually working and helps us talk about it.
That's our mission for this deep dive, really. We want to cover the key ideas of graphing, define the important terms, but in plain English.
Yeah, make it accessible.
And give some real-life examples that you can connect with, things relevant to ABA folks.
We'll also touch on maybe some common hurdles people run into.
And wrap up with some solid takeaways, things you can actually use.
So making it clear, insightful, and practical for your daily work. That's the plan.
Sounds good. So where do we start? The why.
Yeah, let's start right there. Why bother graphing? The chapter gives 3 main reasons. First up, organizing data during collection.
Right. Think about it. You're in the middle of a session, you're recording data, it's just numbers, maybe check marks.
It can feel a bit scattered in the moment.
But if you're plotting that data regularly, maybe at the end of the day, onto a graph, you start to see things shape up, an ongoing picture.
It gives you that almost immediate visual feedback, doesn't it? Instead of waiting till the very end.
Precisely. You see the direction. Is it going up, down, staying flat?
And seeing that direction leads straight into the second point, evaluation. The chapter mentions formative and summative evaluation.
Yeah, good distinction. Formative is like checking your progress along the way.
Like checking the recipe while you're cooking.
Kind of. You're running an intervention. You graph the data day by day or session by session. That graph shows you visually, is this working?
So you can adjust if needed.
Exactly. That's formative. Then summative is the look back at the very end. Did the whole intervention achieve its goal? The graph gives you that overall picture.
Okay, so it's both a progress monitor and the final report card. Makes sense. And the third big reason, communication.
Oh, hugely important. A good graph can often say more than a long written report.
Especially when you're talking to parents or teachers or other team members who might not be steeped in the raw data.
Right. It's a visual tool. You can show the progress or the challenge. It makes the conversation much clearer, much more concrete.
And the chapter makes a really strong point here. A well-made graph should basically tell its own story.
Yes. All the necessary info should be right there. What behavior, when, what happened during the intervention. You shouldn't need a separate essay to explain it.
That's so valuable for IEPs, progress reports, behavior plans.
Yeah.
People need to grasp it quickly.
Absolutely. So if graphing is the key, the most common key we use is the simple line graph.
The workhorse, right. Showing data over time. So let's break that down. What are the parts?
Okay, the basics. You've got your axis, the frame of the graph.
The horizontal one at the bottom, that's the x-axis, and the vertical one at the side, the y-axis.
Correct. The x-axis, or abscissa, if you want the technical term.
Fancy.
Yeah. It shows time, usually days or dates or maybe sessions.
And the chapter notes, if you use sessions, be really clear what a session is. Is it a 30-minute block, a specific activity?
Crucial point. Clarity avoids confusion. And that x-axis, it just goes as far as your last data point.
Okay. And the y-axis, the ordinate.
That's where you identify the target behavior and what you measured. So number of words spelled correctly or percentage of intervals on task.
Got it. And then the scale on that y-axis needs attention.
Big time. Rule number 1, always starts at 0. Always.
Always. No cheating.
No cheating. And the top number needs to be high enough for your highest expected score, or obviously 100% if you're doing percentages.
And how you number it matters too, right? The increments.
Yeah. Keep it consistent and easy to read. Count by 1s, 2s, 5s, 10s, whatever makes sense for your data range. Don't make people squint.
Makes sense. The chapter also had a little tip about raising the 0 line slightly.
Oh yeah, just lifting it off the x-axis a tiny bit. It can make those first few data points, especially if they're low, a bit easier to see. Not essential, but a nice touch.
Okay. Now, what if all my data points are way up high, say between 80 and 90% consistently? All that empty space below 80.
That's where the scale break comes in handy.
Ah, yes. The little zigzag lines.
Exactly. Two parallel, squiggly, horizontal lines on the y-axis. It tells the viewer, hey, we skipped a chunk of empty space here to zoom in on where the action is.
So it lets you see the smaller changes in that higher range more clearly.
Precisely. It avoids that big blank area at the bottom. Use it carefully, but it can be really helpful.
Good tool. Okay, axis, scale. Next are the actual data points.
The little dots, or squares, or triangles. Each one marks the level of the behavior at a specific point in time shown on the x-axis.
You plot it based on the x value time and the y value behavior level.
And each one is its own observation, an independent record of what happened then.
And then we connect the dots.
We do, with the data path, a solid line connecting consecutive points. That line shows the trend, the journey of the behavior over time.
And the chapter says, stick to one shape per data path, right? Like all circles for one behavior.
Yeah, keeps it clean. If you do need to show more than one thing on the same graph, maybe two different behaviors, or data for two kids.
Then you use different shapes.
Different shapes, yeah.
Yeah.
Maybe circles for one, squares for another, and you have to label them clearly, either with little arrows pointing to the path, or more commonly, a legend or key.
A little box explaining what each shape means.
Exactly, but don't go crazy. The advice is usually like max 3 data paths on one graph, otherwise it just gets messy.
Good rule of thumb. Okay, what about gaps? Like if a student's out sick for a few days, you can't just connect the line like nothing happened.
No, definitely not, because the solid line implies continuous data. So if there's a break, you show it.
Oh.
2 main ways. Easiest is just leave a gap. Don't connect the point before the absence to the point after. Or you can put 2 little parallel hash marks, like tiny slash marks, on the data path right where the break occurred.
Okay, shows the interruption clearly. And the last piece.
Gotta know who we're talking about. Put the student's or participant's name, usually in a little box down in the bottom right corner.
Got it. Simple but essential. All right, we know the parts of the line graph. How do we get our different kinds of data onto it? Let's walk through those. Permanent product first.
Okay, permanent products, the physical results, like worksheets, number of items assembled, paragraphs written, tangible stuff.
How do we graph that?
Depends. If the number of opportunities is always the same, say a 10-word spelling test every week, you can just graph the number correct. Simple.
But what if it changes? Like, number of math problems on a worksheet varies day to day.
Then you need percentage correct. You calculate. Number correct divided by the total number of opportunities times 100. That makes it comparable.
Right, getting 810 isn't the same as 1215 until you look at the percentage. The chapter had Catherine's writing example, number of words per paragraph.
Yep. Okay, next up. Event data. Counting how many times something happens.
Like call-outs or hand raises.
Exactly. Again, how you graph it depends. If your observation time is constant, like you always watch, for 30 minutes you can just graph the raw number, the frequency.
So 5 call-outs in 30 minutes today, 3 call-outs in 30 minutes tomorrow. Easy.
Yep. Or if the opportunities are constant, like you always present 10 sight words, you can graph number correct or percentage correct.
And if both time and opportunities vary, like tracking compliance to instructions throughout a whole day,
then percentage correct is usually your best bet. It standardizes the data across those changing conditions. The chapter shows Michael's callouts and Tasha's sight words as examples here.
Okay, that covers counting things. But what about speed? Or when session lengths vary a lot, frequency alone might not cut it.
That's where rate comes in. Rate is crucial. It's number of responses divided by the time period.
Response per minute or per hour?
Exactly. The chapter uses Kevin's math problems. Maybe he did more problems today but took way longer. His rate, his problems per minute, might actually be lower. Rate gives you that efficiency picture.
It's a more precise measure sometimes. Stephen's packet assembly example showed that too, right? Rate per minute.
Yep. Really important when speed or fluency matters.
Okay, moving on. What about behaviors that are more ongoing, like on task or engagement? Harder to count discrete events there.
Right. That's where we use interval recording or time sampling.
Breaking the observation into chunks of time.
Exactly. Predetermined intervals. And you record if the behavior happened during the interval recording, or if it was happening right at the end of the interval, time sampling.
And you graph the percentage of intervals.
Usually, yeah. A percentage or sometimes the raw number of intervals where the behavior occurred. The chapter has Omar's out of seat using interval, and Lean's self-talk versus peer talk using time sampling. Good examples of how that looks.
And they use different keys or legends in those figures too, showing how to label multiple behaviors tracked this way.
Then there's duration data, simply how long a behavior lasts.
like time spent on a task or maybe time spent in a tantrum.
Right. You can graph the total time, like total minutes.
Hmm.
Or you could graph the percentage of the observation period the behavior occurred. Casey's toileting time example shows total duration.
Okay, and one more. Latency.
Latency. The time gap between a prompt or instruction and when the behavior actually starts.
Like how long it takes a student to start working after you say begin.
Exactly. We might not graph it as often as frequency or duration, but when we're working on initiation speed or reducing delays, it's super important. Duchamp's journal writing delay is the example there.
Whew. Okay, that covers getting different data types onto the graph. Now some extra graph features. The chapter talks about conditions.
Conditions, basically different phases of your plan. You always start with baseline measuring the behavior before you do anything.
That's starting point.
Right. Then you introduce your intervention. That's your first intervention condition. Maybe later you change the strategy. That's a second intervention condition.
And how do we show these changes on the graph?
With vertical dashed lines. A line separating baseline from intervention or one intervention phase from the next.
And labels.
Yes. Brief, clear labels above each condition, like baseline, token economy, response cost, centered above that phase. The timeout example in the chapter shows this clearly.
And crucial point, you don't connect the data points across those condition lines, right?
Never. The line break shows the environmental change happened right there. We want to see if the data changes after that line.
Makes sense.
Yeah.
So baseline, intervention, those are our main conditions. Now let's shift gears slightly. Cumulative graphs. How are they different?
Okay, cumulative graphs are interesting. Instead of plotting just that day's score, you add today's score to the total from all the previous days.
So each point represents the total accumulated behavior up to that point.
Exactly, which means the line always goes up or stays flat if the behavior didn't happen. It can never go down.
So what are you looking at then if it always goes up?
The slope. How steep the line is. A steep climb means a high rate of behavior. A gentle slope means a low rate. A flat line, a plateau, means zero responding during that period.
So it really highlights the rate of accumulation. The chapter mentioned using it to show overall progress, especially if the rate starts low.
Yeah, it can be motivating to see that total number grow, even if the daily increases are small initially. Think about learning new words. The total learned keeps going up.
Okay, I can see the use case there. Finally, bar graphs.
Bar graphs or histograms. Instead of points and lines, you use vertical bars.
Each bar is one observation period.
Typically, yes. And the height of the bar shows the value, like number correct or percentage on task, for that day or session.
When would you choose a bar graph over a line graph?
The chapter suggests a couple times. One is if you have multiple data paths on a line graph that are getting too cluttered, and overlapping bars might separate them more clearly.
I can picture that.
Also good for summarizing, like showing the average score for several students on one task or showing one student's performance across different subjects or activities. Figure 5.16 and 5.17 show examples of that summarizing function.
And maybe easier for younger kids to understand sometimes.
Potentially, yeah.
Yeah.
The visual separation of the bars can be quite clear.
Okay. Wow, we've covered a ton. The why, the how of line graphs, getting all sorts of data on there, conditions, cumulative graphs, bar graphs.
It is a lot, and honestly, that can be a challenge for folks in the field, right? Especially early on, just figuring out which graph, how to plot it accurately. It can feel a bit daunting.
Yeah, I remember that feeling. Wanting to make sure you're doing it right.
But it's so worth getting comfortable with, because ultimately the whole point is that clear visual picture. That's what helps us see if we're making a difference. It guides our decisions.
It really is fundamental. Being able to make and read graphs accurately is it's a non-negotiable skill in ABA, isn't it? For tracking progress, making those database decisions we always talk about.
And for communicating effectively with parents, teachers, supervisors, everyone.
So, if someone listening feels a little overwhelmed by all the options, what's the key takeaway?
Start simple. Really get confident with the basic line graph. Understand the axes, the data points, the path, conditions. Get good at plotting your frequency or percentage data accurately.
Master the basics first.
Exactly. Then, as you need to represent different kinds of data or communicate different ways, you can explore cumulative or bar graphs. But clarity and interpretability, that's always the goal.
Well said. So, quick recap. We talked why we graph: organization, evaluation, communication. We broke down the line graph elements. We went through transferring different data types: permanent product, event, rate, interval, duration, latency.
Covered conditions like baseline and intervention, phase change lines, touched on cumulative graphs for total progress, and bar graphs for summaries or clarity.
Okay, so here's something for you, the listener, to mull over.
Your final thought.
Think about a time in your own practice, maybe recently, maybe a while ago, where having a really clear graph could have made a big difference in explaining a client's progress, or maybe the impact of an intervention to someone else, a parent, a teacher, a colleague.
What kind of graph would have been the most powerful in that specific situation? A line graph, bar, cumulative.
And what story would that visual data have told, maybe more effectively than words alone?
That's a great reflection exercise, puts the purpose back in focus.
Definitely. Well, thanks for joining us on this deep dive into graphing. We really encourage you to revisit Chapter 5. Look closely at those figures again.
Yeah, lots of good detail in there. Keep graphing.
Until our next deep dive.